Hi folks. Now that we've learned how to name compounds and write their formulas, we're going to look at how these different compounds interact with each other. And that's going to mean looking at chemical reactions and learning how to write them down. So, what is a chemical reaction? In a chemical reaction, atoms rearrange themselves. You don't create any new atoms or destroy any atoms, you're just rearranging what they're bonded to. So in this image here, we have 4 hydrogen atoms and 2 oxygen atoms, and then at the end of the reaction, we also have 4 hydrogen atoms and 2 oxygen atoms. So the only thing we've changed is what atom is bonded to what. In the beginning, the hydrogens are bonded to each other in hydrogen molecules. The oxygens are bonded to each other in oxygen molecules. And then we break the bond holding the oxygen molecule together. To separate the oxygens, we break the bonds holding the hydrogens together to separate the hydrogen atoms, and then rearrange the atoms into new molecules. When we do this, not only are atoms conserved, mass is conserved. So it's really because of the law of conservation of mass that this is happening. Mass cannot be created or destroyed. So if we start with 4 grams of hydrogen and 32 grams of oxygen, then we better have 36 grams of product at the end. So let's look at some just chemical equation vocabulary first. We need to distinguish between the reactants and the products. The reactants are what you have at the start, the products are what you have at the end. Reactants come before the arrow, products come after the arrow. And so here's a sample chemical equation, and we'll look at each of the bits in a moment. For now, I want you to notice that the reactants come before the arrow, products come after the arrow. Chemical equations are handy because it saves you writing a lot of words. For instance, what I can write in 1 line to express a chemical reaction would take 3 lines for me to type in words. So let's look at the symbols and how it relates to the words. So that arrow symbol means produces or forms. It separates the beginning of the reaction from the end of the reaction. The plus sign just means plus or and. And then in parentheses, we have state symbols. The states can be solid or liquid or gas, as well as aqueous solutions, which are just substances that are dissolved in water. So again, looking at this previous example, we have aqueous hydrogen chloride and aqueous sodium hydroxide react to form aqueous sodium chloride plus liquid water. So that's how you use those symbols to come up with that complete sentence. Let's pick each term in the balanced equation apart. So each term, and by term I mean kind of the components between the symbols. This balanced equation has 3 terms. Each term has to answer 3 questions. How many do we have? That's the coefficient, that number out in front. Of what? That's when you write down the symbol for the chemical, the formula, and then in what state. So you say whether the substance is a solid, a liquid, or gas, or in aqueous solution. It's important when you do this to remember the 7 diatomic elements. So here's an example where this formula would be read, or this equation, you would say hydrogen reacts with oxygen to form water. Well, you need to remember that hydrogen atoms are too reactive to exist on their own in nature. They're always bonded to something else. And if it's hydrogen, elemental hydrogen, then it's bonded just to itself. If there are no other elements there, hydrogen atoms will bond to themselves. There are these 7 diatomic elements that we talked about before in Module 3. Please remember them now when you're balancing equations. All right, so let's practice. 2 atoms of aluminum react with 3 units of aqueous copper 2 chloride to produce 3 atoms of copper and 2 units of aqueous aluminum chloride. I'm using this word units here because this is not a covalent compound. you only have molecules when you have a covalent compound. So how do we write this as an equation? Well, for each substance, we have to say how many of what in one state. So aluminum and aqueous copper 2 chloride are reacting together, so those are going to come before the arrow. And so we have 2 atoms of aluminum, and aluminum is a metal, and most metals are solids, so that's going to be solid. React with 3 units of aqueous copper 2 chloride. This is where you need to know your formulas. Copper with a charge of 2, chloride has a charge of -1. To produce, this is our arrow. Oh, I forgot to do the aqueous. To produce, this is our arrow. 3 atoms of copper. Copper, again, is a metal, so it's a solid. And 2 units of aqueous aluminum chloride. So, and 2 units of aqueous aluminum chloride. And we need the aqueous symbol. All right, here's another example. Aqueous solutions of lead 2 chloride and sodium chromate. So these are my reactants. React to produce a precipitate, remember that's a solid, of lead 2 chromate and an aqueous solution of sodium chloride. So we're going to have lead 2 chloride, lead with a charge of 2, chloride has a charge of -1, so this is my correct formula. Reacts with sodium chromate, sodium has a charge of +1, and chromate is CrO4 with a charge of -2, so this is Na2CrO4. Lead 2 chromate, PbCrO4, because lead still has a charge of 2 and chromate still has a charge of -2. And sodium chloride. Sodium has a charge of +1, chloride has a charge of -1, so sodium chloride. Now, with this equation, the previous equation I showed you was actually came with the coefficients to make the equation balanced. But if you look at this example, this is not what we would call a balanced equation because, well, we have lead on both sides of the equation. We've got 1 atom of lead on each side. With the chlorine, though, I've got 2 atoms of chlorine over here, but only 1 over here. So I'm not conserving atoms. I'm not conserving mass. If I continue on, sodium, there are 2 sodiums on this side, but only 1 on that side. And then with the chromium and the oxygen, there are 4 oxygens and 4 oxygens, 1 chromium and 1 chromium. So what I need to do is have 2 sodium chlorides so that this equation will be balanced. So that's what we're going to look at next. How do we go about balancing an equation once we've learned how to write it?